word to you, Dmitry and Alexander.
Okay, thank you, Anton. Uh, Today we are gonna talk about Velostrata, but I'd like to note that we have already shown this presentation as part of DevOps Days, but we were asked to do it again. Well, for those who have already seen it, nothing new will happen today. Velostrata is a migration tool from Google. In Google documentation now it's called migration for compute engine. But before we will switch to Velostrata topic, let me describe our migration process. The first step is migration discovery. At this phase, we will need to collect data about customer infrastructure. Second step is preparation. At this step, we need to decide which VM can be migrated with Velostrata and which should be upgraded or should be migrated manually. At configuration step, we will prepare on-prem site and GCP site for migration. The migration phase is a directly migration process, and during the knowledge transfer, we'll tell you about tools which we installed and how to use it, and we will help you to use migrated environment and to operate by yourself. Let's start with the first step of the process. It will be tools called Cloud Physics and Stratazone. Cloud Physics supports two environments. It's AWS and VMware for now. Cloud Physics has an agent, and this agent should be deployed in vSphere from OVF or OVA template. With Cloud Physics, you can know which VMs meet requirements or should be upgraded. Cloud Physics pulls CPU, memory, and disk load information directly from vSphere or AWS. And with Cloud Physics, we can create TCO reports for comparing costs in GCP site and vSphere or AWS. This is an example of this TCO report. Only one screenshot of this report. And next tool is Stratazone. Stratazone supports more platforms than Cloud Physics, among them such as vSphere, AWS, Azure, and bare metal servers. Stratazone has agent 2, and for this agent you will need Windows machine, which should have access to VMs that are being analyzed. And Stratazone shows a more detailed view of the VM in data center. With Stratazone, you can see what's running on these VMs and how they are interacting. Stratazone agent called StrataProp, and StrataProp connects to VMs via SSH for Linux machines or WMI for Windows machines. Once we automatically collect the information through our tooling, we can do some quick analysis for this information. Just for understanding, can we use automated tooling like Velostrata, or we should use another way? For example, manually migration. In order to do such quick analysis, we have to look at the following questions. What is the VMware ESXi with Sphere version, current usage on-prem? Is it possible to build the VPN tunnel from existing infrastructure? Do you store the data at local disk for the list of migrated VMs? Do you have data, network, and any other dependencies? It's not full list of questions. Full list is available is here under the link. Now let's come back to the Velostrata overview. Velostrata contain Velostrata Manager, Cloud Extension, and Velostrata Exporter at GCP site, and Velostrata Backend at on-prem site. Velostrata Manager manages all components and orchestrates migrations. It is also the Velostrata Web UI. Cloud Extension is a pipeline for VM storage between two hosting environments. Velostrata Exporter creates Google Cloud persistent disks when detaching disks. And the Velostrata backend stream data from VMware to the cloud extension. Now let's discuss the prerequisites for Velostrata at GCP site and on-prem site. At GCP site, we should have created account, organization, and project. In this project, we need to create VPC and create service account. Service accounts can be created with Cloud Shell. Next prerequisite at GCP site is firewall. We should have accessibility between the sites and the firewall ports opened. For example, we need to open 443 port for Velostrata Manager Web UI, SSH port, and RDP ports for accessing to migrated VMs and other ports, which you can see in this slide. At on-prem site, we need to configure firewall too. Velostrata backend should have access to vCenter server or Velostrata manager. For this, we need to open following ports, which you can see on this slide. This is our network scheme, which we will use in our demo. In this scheme, we create. You can see we create a VPN tunnel between GCP and VMware. At on-prem site, we have a virtual machine with public IP. In this VM, we install StrongSwan and build a VPN tunnel between GCP and on-prem. And between this machine with StrongSwan and our data center, we built IP tunnel. Another option is to use an alternative scheme. This design can be used if you don't have public IP for some reason on VMware site. But the scheme is more difficult to implement due to more network settings on both sides. You will need to configure additional routes, firewalls, and enabling IP forwardings. And maybe you will have some another issues. Let's take a look at another prerequisite for Velostrata, which is Velostrata Manager. Velostrata Manager should be deployed from Google Marketplace. It's very easy to do. You just need to click Launch on Compute Engine and follow the instruction by filling in the fields using the data obtained in the previous steps. For example, service accounts and etc. After you deploy Velostrata Manager, you need to deploy Velostrata backend. But for this, we need to create a service account in on-prem site in Vsphere. We need to create a role and add to this role privileges. Full list of privileges you can see here under the link. And after that, you need to assign this role to a user in VMware. After that, we can deploy Velostrata backend. For this, we need generate token in Velostrata Manager Web UI. This token valid for 90 minutes. Only one token valid at a time. This token includes internal IP address and some additional information which you can see if you read this token with base 64 in decode mode. The next step is to register a vCenter plugin. For this, we need only specify DNS for vCenter and or IP address and credentials for vCenter. And finally, let's register a cloud extension. Cloud extension can be added from Velostrata Manager Web UI or from Vsphere. We suggest to do it from Velostrata Manager because Vsphere is using Flash plugin, which is unstable. In our case, we have only one cloud extension, but you can add more than one. It depends how much you need to migrate virtual machines. Cloud extension supports up to 15 concurrent migration streams. The example of the calculation of cloud extension you can see on this slide. That's all from my side. Now Alexander Gubanov will tell you about the migration process and show a small demo.
Hi guys, I'm Alexander Gubanov, DevOps engineer at Critical Service Unit. I will cover the remaining part of this presentation, show a small demo. As for now, we have already configured Velostrata Manager and Velostrata backend. So all preparation regarding infrastructure are finished, and we can switch especially to the migration. But before we start talking about migration, we just need to answer on the question, is there operation system of your instance that you want to migrate supported by Velostrata. By support, I mean that Velostrata provides us streaming and caching technology. It's like main feature of Velostrata. It means that in few minutes after you start the migration, you will have running instance in GCP site, but the data, the storage is streamed from on-premise until it copied. So the operation system of your instance should support by Velostrata. Here is a list of supported operation system, but I just need to clarify that all modern operation systems are supported, and only like old one like CentOS 5 or Ubuntu 12 or Ubuntu 2012 do not support, and you should use the offline migration. I will talk about the migration cases a few slides later. So once we're done with that, we need to install few packages to prepare our instance for migration. For Linux, we need to install like a package with scripts that may change in a boot process. Here under the link you can find package for your distributive, and also you need to install VMware tools. By default, it already installed and running for Ubuntu or Debian, and you need to install and run it for CentOS or Red Hat. So these two packages you need. And for Windows, you just need to install VMware tools. You can do it via summary tab at vSphere. Just mount the ISO and proceed with installation inside the guest OS. So that's it for the configuration. Let's talk about migration cases. The first one, it's running cloud. How it works. So when you run the migrate, Velostrata marks the migrated instance as managed and creates snapshot, create the image from this snapshot and boot the instance in GCP site. At the same time, the data, the storage is streamed via SCSI. So like in a short period of downtime, you have up and running instance. Another case, it's migrate, or another name is full migration. It includes the previous step running cloud and has two another sub-steps. So the second sub-step is storage migration and prepare to detach. I will talk about that a bit later. As I mentioned before, we have offline migration for operation system which doesn't support streaming. So everything here goes offline. You need to copy storage before and after that do offline migration. And another one case, it's a test clone. It's similar to running cloud, but the difference between them that test clone won't affect your on-premise instance. So at on-premise, the instance still keeps up and running, and Velostrata just creates a snapshot and run it in GCP side. So like you have two versions of the same instance in different places in GCP and on-prem. Velostrata documentation suggests us to use this case first when you just start your migration, just to ensure that everything works fine. And if everything okay, you can proceed with normal migration, which is migrate or full migration. And move back, it's another case for example, if you have already migrated instance in GCP, and for some reason you need to move back this instance to on-premise, so you can do it, but before you press the detach operation. Here, how migration process looks like in general. So we have three main steps. It's a full migration, detach, and cleanup. Full migration consists three sub-steps. As I said, it's running cloud. When we have Velostrata shut down the instance, create snapshot, boot in GCP side, storage streams, and as background process, it has the second subset, storage migration. So in the background, we have the data is copied. And once we have copied the data to GCP side, we have prepared to detach step. It means that instance that already runs in GCP side may generate a new data, and this step handle situation. So it syncs the new generated data and data that were copied, and it creates the exporter node. In more, I will talk about that on next slide. So after we have copied the data and instance is running, we can proceed with detach operation. It's like second big step. Here we have another one downtime where we can change the machine type of the instance, and Velostrata just attaches the native disk to migrated instance, and that's it. And the last one is cleanup, where Velostrata deletes all temporary files and marks the instance as unmanaged. So you can proceed the migration once again if you need. Migration can be done in a few ways via with sphere extension or via migration waves. Yes, so when you start the migration, you need to choose storage policy. As I said before, new instance that already run in cloud may generate new data, and so on this step we need to answer an equation: are we going to write back the new changes to on-premise when migration is done? So we have write back, it's a default mode, and write isolation, we do not write back the new data to on-premise. that's it that you need to know about storage policy. And let's talk how migration process works under the hood. Here I will describe about this process based on write back mode. So when we write back the new changes to on-premise. So when you start migrate, you press migrate in vSphere. Velostrata marks this instance as managed, shut down it, create snapshot, create instance, boot it in GCP side, and storage streams via SCSI. As background process, we have storage migration, and when storage is copied, we have step prepare to detach that creates additional instance exporter that builds native disk and keeps sync with new data and data that copied. After that migrate is complete. Next step is detach. Here, as we have write back mode, exporter perform last synchronization, attach the native disk to the instance. Here you can change the machine type, yeah, and write back the changes to on-premise storage. After that, it deletes the exporter. And the last step, cleanup, as I said, mentioned before, delete temporary files and marks instance as an unmanaged. There are a few, as I said, there are a few ways how we can migrate via vSphere or via migration waves. In this presentation, I will use vSphere because I guess it gets better understanding how everything works. You need to proceed step by step all operation. So, but it has like some limitation. You need to log into vSphere in Flash version instead of HTML, because HTML does not support, it doesn't show you the migration options in context menu. So here is the first limitation. In vSphere, there are two migrate options. The first one is the standard for life migration, and you need to choose migrate for GCE operation. So this option that we need. Also, you can check the progress at the summary tab of instance and see what step now is so I believe for now we have you have enough information about the migration, and I can show you a small demo, and after that get back to the presentation. So we have, here is GCP site where we have Velostrata Manager, two instances that handle the streaming. It's Velostrata Edge nodes. And here is our Lviv data center where we have instance with Ubuntu. I believe it's Ubuntu 16. I don't know. That doesn't matter. It supports streaming. So it has small storage just to speed up the demo. So here we can choose, as you see, it's migrate, and here is option that we need, migrate for GCP operation. We just need to start migrate. After that, so here we need to choose cloud extension. It's 2 nodes that I showed you before that handle the streaming. We have only one because we don't need a lot of instances that we want to migrate at once. I mean, the one cloud extension, it's these 2 nodes, supports up to 50 concurrent migration. For now, we just need to migrate only to 1 instance, so 1 cloud extension, it would be enough. So just press next. Here we need to choose storage policy. Do we need to write back new changes or not? I leave it as default. Next. Here is network settings on GCP side. Also leave it as default. By the way, I forgot to just to show that everything works, and this is not like a fake. I want to show you that everything works. I create the test file, and we check it after the migration on GCP side. So here is it. Let's back. Yeah. So we here we can choose the project instance type for and service account. I leave as default, and disk that will be created in GCP side. So that's it. Next, just summary and finish. After that, the migration is started. Here, the icon of this instance should be changed as, it will change in few seconds. Just to speed up the demo, I have the same instance with the same Linux, Ubuntu, and the same storage, but it already in ready to detach step. So it means the storage is already copied. So we can continue migration. So this what I want to show, that this instance will be in the same state as this. So we continue the migration with this, and after that get back to the previous. But just to show that how write back mode works, I want to connect to this instance. By the way, here is GCP site. As you see, we have demo VM already running, and here is exporter node that handles the new data. So it's like not the handle new generated data, and if needs, it write back to the on-premise. So just to check it, I want to connect to this instance. create the file, and once migration is done, we will check it on on-premise side. So we check how.
Yeah, Alexander, can I interrupt you? I prepared this instance, and I want to note that this instance was migrated in bright isolation mode.
Oh, okay.
You can't show this.
Okay. So no, I don't show you. I will not show you. Anyway, it works. So I just can run the detach. So it's second step, as I described before. And after that, yeah, here we still can recreate the instance with different machine type. I leave it's default. And after that, the migration should start, the detach step should start. The information here updated in a few seconds. As it's Flash version, sometimes it works not so well. So yeah, as you see, here is the information about the first instance that we just start migrate. Okay, let's get back to the presentation. As I said before, we have two ways how we can migrate, and another way it's migration waves. It's like web UI that provided us by Velostrata Manager, and it can be used in case when you need to migrate a bunch of VM. So like if you have like thousands of VM and you need to migrate at once, you need to use migration waves, because in case of Velostrata, you need to proceed the migrate for each instance one by one. It's not good in like production. So yeah, Velostrata provides us this way. It introduced two concepts: runbooks and jobs. So runbook is just CSV file that where we can specify all settings as I specified for vSphere, like storage policy, instance type, network settings, and so on. And job, it's just operation, some migration operation, like clone, full migrate, detach. So this kind of operation. And how it works? You log into Velostrata Manager, choose migration waves, press the generate runbook. After that, you download this CSV file, edit it, leave only instance that you want to migrate, update the settings for each. After that, upload it, validate, and proceed with all operation, like full migration, detach, cleanup. You need to use this three-step one by one, even for migration waves. So Velostrata works well, but until you faced with some strange issue. Here is some list of the issues that we faced during the testing on our lab. So one of them was that we migrate instance with Ubuntu, but that has Windows in settings. And after the migration, it failed because it can detect some disk. And we need to resolve this, we need to just change the guest OS in the instance settings. So just to avoid this mismatch. Another case, we have Velostrata manager and backend, and we want just to deploy another one manager just to ensure that we cover all installation parts and try to register one more manager with backend. You can do it because only you need to deploy new one. So and another case that we deploy new one pair of the Velostrata manager and backend, and when we start the migration via vSphere, we faced with the issue that vSphere can't connect to, tries to connect to all Velostrata backend, which is already was deleted. So it's a Flash plugin cache issue. We try few ways, but nothing helped, and we resolve it by restarting the vSphere web client. I'm not sure that it's a good way because during the restart, you like vSphere API and web UI is not available at least 10 minutes in our case, and but yeah, your instance is still working, just web UI or API is not available. Maybe there is some another case how to resolve it, but if you know, ping me. And the like a summary of this presentation, that we tested the migration. We have two cases like with two tunnels, IPsec tunnel and OpenVPN. IPsec works faster. We have 95 to 54 megabits, and OpenVPN just 10 to 10 megabits. But we use OpenVPN as workaround. We, as IPsec requires for public IP, we don't have it. So we, as workaround, we use OpenVPN. We tested like concurrent migration of 3 instances with Linux Ubuntu and 20 gigabytes disk each. And here you can see that how each step takes. It's statistic of migration via migration waves. So as you see, almost 50 minutes we copied the the data and run the instances, and detaching cleanup was very fast. So you can, based on this time, you can calculate how migration may take in case of 1,000 VM. So I did the calculation for real project for 50 terabyte data, and the speed should be 800 megabit or even up to 1 gigabit, and it should take 5 days. But we still haven't checked, haven't got the final result of this. Yeah, here is the link of this presentation. Just for your convenience, we gathered all topics that were mentioned here. Most important, here is a link to, it's like our SoftServe internal materials provided by Velostrata. It consists a lot of details how everything works under the hood. Because for now, official documentation provides very high level description what and how something works, and these materials have much better describing how everything works. Yeah, I believe that's it. We can get back to our migration and check the status of instance. Yeah, so as you see, the instance already ready to detach, so it's already running. Here you see demo VM. We can connect to this instance and check the file that we created earlier. Yeah, here is it. Everything works. So I believe that's it. If you have questions, we can answer on it. Thanks.
Hello, I have a question.
Yeah, hi.
In comparing to bandwidth limitation IPsec and OpenVPN, what is the bottleneck on the Google Cloud or the client? And can we increase the bandwidth using more power hardware on the client side?
Yeah, so documentation suggests that we need connection at least 20 megabits, but as you see, it works even for 10 megabits. So the documentation suggests us to use Cloud VPN, but you can use dedicated interconnect, or even I don't remember how another connect with more speed calls, but yeah, you can use it. The limitation here is the speed, and another limitation that I heard, but I haven't faced with it, that when we have when storage is copied for a bunch of VM, the load on the storage on-premise is very high, and it like we have issues with with Sphere, so it's work very slower. But I just heard about that. I do not face with it. Am I answered on your question?
Yeah, so no limit from the Google side.
So for I don't know, just speed or
yes, just speed. So we have no limitation on the Google side. If we will have our hardware more powerful, we will have our speed increased.
So yeah, another limitation may be like limitation of your project, like quotas of disks, and another limitation that we need to deploy cloud extension. It's two instances that handle the streaming. If you migrate the if you want to migrate more than 50 instances seamlessly, you need to deploy one more cloud extension, and Velostrata load balance between them. I don't know.
Okay. Yeah, thank you. Yeah.
Okay, another questions?
Looks like no question. So thanks guys for pretty useful topic. And additional thanks for agreeing to share your experience with us. I know that